Alright, let's look at example 3. Um, and so in this problem, you're not given a function, but you're just given data points in the specific context. So we see a table below representing the velocity, v of t, in feet per second of a car traveling on a straight road. And it's asking us to approximate this symbol, which once again is the integral from 10 to 50 of v of t dt with a left, right, and midpoint Riemann sum of 5 subintervals of equal length. And I made a typo here. If you can actually change that 5 to a 4, that would be awesome. Sorry. And you'll see why this doesn't quite make sense in this problem. So let's start with the left. So on a left Riemann sum, if I were to just pretend there's a curve, I'm just going to estimate what this looks like. I know it's at 0, 0, 5, 14, maybe 20, 28, 52, 70, 74, 83, kind of goes back down, maybe something like that, right? So let's say we just had a curve. I'm just sketching it for our purposes here. We want a left Riemann sum from 10 to 50. So here's 10 and here's 50. And so we're gonna basically go from here to here. And so for a left Riemann sum, remember we're taking the left corner and drawing our boxes. So something like, so we need 4 subintervals, right? So that means if we want to find our subintervals delta x, then we know it's going to be b minus a over n, and that is equal to 50 minus 10, which are the intervals, over the number of subintervals 4, and so that's 40 over 4, which is equal to 10. So each delta x is equal to 10, and so I actually drew this, and I think I accidentally made my delta x 5, which is not correct. It should be 10. So let me just say this is 20, 30, 40. And so from my left corner, here's my first subinterval box. There's my next corner for a left. Here's my next corner and my next corner. Okay. All right. So to figure out what the total area under the curve, if we were to approximate the area using Riemann sums, we know my delta x is 10. That's my width. And we can multiply it by the heights of these 4 rectangles. And so the height of this first rectangle, 1, 2, 3, 4, the height of this one, first rectangle 1, is going to be this height right here. So maybe I'll highlight. So that height, that height, that height, and that height. And so I know the height of the first rectangle is going to be f of 10, which is because this is the x value. Or in this case, maybe I should say these are the t values and these are the v values. So I shouldn't say f of 10, I should say v of 10. And this one is v of 20, v of 30, v of 40. So v of 10, so here's the time 10, and here's the v of 10. So 20 plus the v of 20, which is 52, the v of 30, which is 74, plus the v of 40, which is 77. And there you go, that's the area of the left Riemann sum. So let's move on to the right Riemann sum. Now I'm not going to draw a visual for this one, because as you can probably tell, maybe I will draw the visual. I'll just choose a different color. I'm going to overlap. So for a right Riemann sum, remember we don't do the left corner, we'll do the right corner. So it'll actually look like this. So there's my first one, my second rectangle, my third rectangle, and then my fourth rectangle. And so in this case, we know the area is going to be, once again, the width times, but now it's going to be the V of 20, the V of 30, the V of 40, and then the V of 50, because it's the right corner, right corner, right corner, right corner, right corner, right? So I'll just write V of 20 plus V of 30 plus V of 40 plus V of 50, which is equal to, it's just going to equal 10 times the V of 20, so it's this one, 30, 40, and 50. So we have 52 plus 74 plus 77 plus 74 again, and that is the area for the right Riemann sum. So let's do our last one, a midpoint. Now, remember, the midpoint is not going to be the left corner or the right corner, but it's going to be right in between. And so, maybe I'll do purple. So these values are going to be the heights of the rectangle. So the height, oops, I went too far. Right there, this is going to be the height. Right there is going to be the height. Right there is going to be the height. And there. And what are the heights of these guys? It's going to be the V of, what value is that? 15. So there's 15. So the height is going to be V of 15. So if I were to do the area, it's going to be 10 times the V of 15, which is the midpoint of the box 1, plus the midpoint of box 2 is going to be V of 25 right here. Then the V of 35, and finally the V of 45. Put them all together, 10 times V of 15, V of 25, V of 35, V of 45. So we have 28 plus 70 plus 83 plus 62. So there we go, we got the left, right, and mid. And I guess if we put answers to all these, we'll have 10 times 20 plus 52 plus 74 plus 77. Our left Riemann sum will be 2,230. Our right Riemann sum, and here's a trick, second entry to bring up everything, and we know all the numbers are the same except the, let's see, 77. So we'll need a plus 74 at the end, because we're basically just shifting over, and we're just going to take out the first one, that first left Riemann sum height, and there we go, and you get 2770. And for the last one, we'll have to redo, and we got 28 plus 70 plus 83 plus 62, and we get 2430. 2430. Awesome. Awesome, awesome. So we have approximated this, and because this is a context of a more real life scenario, we can actually find units for these three approximations right here. Now, what do you think the units are going to be? If you think about the problem, what did we just find? We found an area, right? And so what is the area of this V versus T curve? The area is basically, we basically found rectangles. And to find the area of a rectangle, you multiply the base and the height. So what is velocity, which is the height, times the time, which is the width? And so if you think about it, we have the velocity right here and the time, multiply them together. What is feet per second times second? It's feet. So the units of this guy is feet. These are all feet. Awesome. So there we go. That's part A. We've approximated the feet of this expression right there, the integral from 10 to 50 of v of t dt. Now in part B, they're going to ask, what does this mean? What does this mean? Let's go to part B. What is the meaning of this? So let's just take the midpoint here. Let's just pretend this is going to be our representation. We found 2,430 feet. Now, what does this mean in this context? So we have a car traveling, and we calculate and approximate this value, and we find that it's feet. So what does the area under this mean? Under this curve mean? It means feet, but what does it actually mean? So what this means is we're going to say the displacement. It's a physics word, which basically, not displacements, but displacement, which basically just means how far did you end up from where you started. Displacement means, I guess, distance away from where you started. Now that makes sense because, a car's traveling forward, and it's changing in its speed, but they're all positive speeds, right? So it's like, at the end, we're going to find that the car, over a time of 50 seconds, is going to have traveled some amount of distance. And so this area represents the total, how far the car is away from where it started. Okay, that's displacement. Right. All right, so what is the meaning of that? Now, displacement is right. So here's how I would formally write it. So I would say this expression, the integral from 10 to 50 v of t dt, is 2,430 feet, which is the displacement of the car from time t equals 10 seconds to t equals 50 seconds. Okay, so let's highlight some key points that we gotta include. So anytime they ask for the meaning, I would include the actual value with the units, the actual meaning of the integral expression, and the time interval. Okay, those three things are important. Whenever they're asking for the meaning of something, you gotta have 1, 2, 3. Okay, the actual units and the value, the actual meaning, like what the integral represents, and finally the time aspect. Because let's say I didn't put time t equals 10 seconds to 50 seconds. What if I put t equals 10.3 seconds? That would be a totally different answer, because then the problem would be 10.3 to 50. Does that make sense? Instead of just 10. So this time aspect is also very important. Okay, and so here is the example 3 of this problem.